Okay, so having a wee go at this one here. I'm just going to split the integral up as normal. So bring the 7 outside. Cosec squared 3x dx minus 6x dx. Now, do I have the derivative of the bottom on top? Yes. So you log the bottom. Cosec squared, where did it come from? Now, cot goes to minus cosec squared. So it's going to go, I need a minus in there, balance outside. Derivative is 3 and balance outside with a third. So you've got a third outside your bracket there. And cosec squared goes back to cot 3x. To differentiate or integrate this, add 1 to the power, divide by it. And then just tidy that up. So it's a third cot 3x minus 3x squared add c. Okay, so from the same year, the different paper. So let's just get this one up so we can see. Okay, looking straight at that is integration by parts because it's a product. So u is the easier one. So do du by dx. dv by dx is the more awkward one. Now, I like to write it in integral signs when I'm finding v. Sine goes to cos, so it will just go back to sine. The derivative is a 2 and balance outside. So that just goes straight back, half outside and straight back to sine 2x. So, using your formula, uv equals minus the integral of v du by dx dx. So it's u times v, so I'm going to pop that half in front. Take away the integral of v, so I'm going to pop that half in front again. Sine 2x, du by dx is a 1, so I don't have to put it in. Okay, where does sine come from? Well, a cos goes to a minus sine. So I need to have a minus in there, balance outside. The derivative is a 2, balance outside with another half. So the first one sits as it is. 2 minuses, a half times a half is a quarter. Sine will go back to cos 2x, and don't forget your c. Part B is asking us to use a substitution. So let's do our du by dx. Cot differentiates to minus cosec squared. So let's see what we have here. 1 plus cot is u squared. E to the cot, e to the u. dx, if I rearrange this, so du equals minus cosec squared x dx. So bring this over. So du over minus cosec squared x dx. It's not looking too pleasant, but we'll just put your dx in here. Du over minus cosec squared x. Right, cot and cosec are linked. 1 plus cot squared gives me cosec squared x. So if I bring this across here and move these two over, basically just change all the signs. Minus cosec squared x equals minus 1 minus cot squared x. And you know that cot is u, so it's minus u squared. Okay, so I'm going to put that as my minus cosec squared. So I have got up here 1 add u squared eu minus 1 minus u squared for my cosec squared du. What I'm going to do now is I'm going to take the minus out of that bottom. Now it's starting to collapse down. I'm left with a minus eu du. So put the minus outside the integral. To integrate an e, derivatives in front, derivatives is a 1. So that just integrates straight back to eu plus c. And your u was cot x and plus c. Okay, and number 8 from this paper. Right, first of all I have to find these intersection points. So that's when y is 0. So that's the first thing. So I put sine x plus cos x equals 0. If you ever have sine and cos in the same expression or same equation equaling 0, just divide everything by cos, because sine divided by cos is tan, cos divided by cos is 1. So you've got tan x equals minus 1. So your basic angle is inverse tan 1. So on your calculator, inverse tan 1 to give you pi over 4. C-A-S-T. Your tan is negative, so it's in these two quadrants. So not pi over 2, pi, 3 pi over 2, and 2 pi. Now, I need to work out, it's this one here I'm looking for. So it's going to be in this quadrant. So the angle is going to be pi minus pi over 4. So it's 3 pi over 4. So now I can start thinking about how to integrate this. I'm going between 0 and 3 pi over 4. And it's going to be, volume is pi times your y squared. So putting pi outside. Now squaring your y. Now to square your bracket, you square the first, you square the last, and you double the products. The sine squared plus cos squared cancels down to a 1. This here is going to cause me a problem. So I've got to think to myself, what equations do I know where I have got sine and cos together? And the one that springs to mind is 2 sine x, because it's 2 sine x cos x. So I could write that as a half sine 2x, just bring that 2 across, is sine x cos x. So what I'm going to do now, put that outside, first integral plus this second integral. I just noticed I didn't need to do that. I could just write that second integral as sine 2x. Now, where did sine 2x come from? Let's integrate this one first. Cos goes to minus sine. So in balancing, derivative is 2, balance outside. So it's a minus a half cos 2x. Your limits. Now, pulling it all together. 3 pi over 4 minus a half cos 6 pi over 4, which is 3 pi over 2. Take away. Putting in 0. Cos 0 is 1. So cos 0 is 1, so that's minus a half. Nearly there at the end of this sum. So it's cos 3 times pi divided by 2 is 0. Plus a half. So I'm left with pi, 3 pi over 4 plus a half.